set it equals 0. That's good. Anything else?
Yeah, or you want to solve for pi sub 2, right?
Right, exactly, yes. Because there are two variables here, two partial derivatives. So pi 2, which by definition is partial pi partial q2, which will equal what?
P minus 2q2 minus q1.
Okay, let's put this one first, so we keep them in order.
Okay.
So it'll be just a minus q1 minus 2q2. And we set that as low 0, 2. Those are our two first order conditions. Now earlier, the notation was f sub x equals 0, f sub y equals 0. But now it's really pi sub 1 equals 0, pi sub 2 equals 0. Then, see if you can find values for q1 and q2 that simultaneously satisfy both of those conditions. And, I know we didn't do matrix algebra, but let me just teach you a good trick here. It's called Cramer's rule. A very nice way of solving a system of linear equations. Let me rewrite those two first order conditions. Just bring the q1 and the q2 over to the right. And then flip it. So I'll rewrite that first equation as just 2q1 plus q2 equals 100. Okay. And the second equation we could write as q1 plus 2q2 equals 80. Now the q1 and q2, notice they're aligned in columns. q1 in the first column, q2 in the second column. So if you write it that way, then Cramer's rule is just this. If you want to solve for q1 star that satisfies that linear equation system, you do the following. In the denominator, you calculate the determinant of the coefficient matrix. The coefficient matrix is just 2, 1, 1, 2. So you take this and use vertical lines to indicate determinant. This is not absolute value. Now means determinant. So you put a 2 here, a 1, a 1, 2. Now in the numerator, you also calculate the determinant. What you do, get a q1 star, you take this right-hand side vector, 180, and you substitute it for these coefficients 2, 1. So this becomes, instead of 2, 1, this becomes 180. Then the rest of it is just the same as it was before, 1, 2. You're substituting the right-hand side constants in for the first column, where q1 is. Then you calculate these two determinants. This determinant here is 100 times 2, that'd be 200, minus 1 times 80. Down here, the determinant here is 2 times 2 is 4, minus 1 times 1, 4 minus 1. So this means q1 is equal to 120 over 3 equals 40. Using Cramer's rule to get q2 star, you would just do this. q2 star is, it's the same coefficient matrix down here, 2, 1, 1, 2. And this first column will be the same as this one, because we're now doing q2. So you substitute in the right-hand side constants in the second column. This would be 180. Okay. So what will this be? This will be This is the same as before, 2 minus 1 is 3. This is 160 minus 100 is 60. So this is 20. And let's just check to make sure that works, because I could have made a mistake somewhere. You're all getting tired, nodding off. So you may have not noticed it, but I may have made a mistake. So let's just check. Q1 equals 40, let's see. So that would be 100 minus 2 times 40, that's 20. Minus 20 is 0. Yep, that works. And the second one also, this is 40 here. So 80 minus 40 is 40, minus 2 times 20, yep, it works. So that is the solution. Furthermore, we know whenever this determinant of the coefficient matrix is not 0, that means the solution is unique. If you have a linear equation system, this determinant of the coefficient is not 0, it's 3 here. So not only does this solution work, but it's a unique solution. Okay, it's the only solution. Okay, so what does that mean? It means the critical point, now we'll call it Q1 0, is 20. Q2 0, oh, wait a second, I made a mistake there. Q1 is 40, not 20. We just solved one, it's equal to 40. Q2 is the 20. This is the critical point. The first order conditions are satisfied here. Now, how can we be sure that this production level for Q1, Q2 gives us the maximum profit? Not the minimum. Or, yeah, check the second order condition. Now, what is pi 1, 1?
-2.
Negative 2. What is pi 2, 2?
-2.
Negative 2. What is pi 1, 2?
-1.
It's equal to negative 1. So in this case, both of these second order derivatives are negative, and pi 1, 1 times pi 2, 2, that's like f sub xx times f sub yy, is equal to 4, and pi 1, 2 squared is equal to plus 1. 4 is greater than 1, so that guarantees that the second order sufficient conditions for a maximum are satisfied. In other words, if you look at this profit function, the surface in 3 dimensions, it looks like a hill. On the top of the hill, the maximum profit occurs right here. If you go back and substitute these values in for Q1 and Q2, you'll get the maximum profit. And let's just go back. Help me out. What was our objective function? I've erased it.
100Q plus 80Q of revenue minus cost, which is,
Yeah, okay, I remember. Is that right?
yeah.
Okay, so just plug in our values of Q1 and Q2. Hopefully it'll be positive. Hopefully we'll get a positive profit. We know it's a maximum regardless. Let's see what it is. It's going to be 100 times 40 plus 80 times 20 minus, I'll put the minuses down here, minus 40 squared minus 40 times 20 minus 20 squared. So what will this be? 4,000 plus, what's it, 1,600? Watch me make sure I don't make a mistake. Minus 1,600 all right, 40 squared. Minus 800, minus 400. So what is this? This would be 5,600 minus 1,600. Well, let's add these up. What are all the minuses? This would be minus 24, wouldn't it? Minus 24.
Wouldn't it be easier to
Minus-
just cancel the 1600s?
Okay, well, that's a good idea. All right, let's just do that. Very good. Didn't see that. That's very good. So it's 4,000. Minus 1,200, right? Which would be equal to, what, 2,800? So that will be the top of our profit here. We get $2,800 in profit by producing 40 units of good one, 20 units of good two. And that would give us the maximum profit. Top of the profit. Hill has a height of 2,800.
Quick question.
Yes,
If we had a three-product firm,
yes.
we would still be able to do the math, but the only
Yes.
difference is we couldn't craft that?
Right, because see, then you say you have a Q1, Q2, Q3.
Right.
You're already in 3 dimensions, but profit would be the 4th dimension. So you could still do it mathematically, but you wouldn't be able to show it graphically. Exactly right. So, and by the way, the first order conditions, if you had 3 products, pi 1 equals 0, pi 2 equals 0, pi 3 equals 0. Now, the second order conditions are a little messier, but there's a systematic procedure you could use for the second order conditions, and I'll show you that tomorrow. We might briefly talk about 3 products for some. Yes. Very good. That's all for today. Tomorrow we will meet again at the regular time of 9:30. And I hope,